Greetings there everyone. So in this video we'll be dealing with gamma function, especially some aspects of gamma function like the definition of a gamma function and some of the basic or even the fundamental properties of gamma function. Alright, so gamma function is a generalized factorial function, and literally we dealt with factorial function in our previous sessions, like the n factorial is equal to n times n minus 1 times n minus 2, and this goes like to 3 times 2 times 1, like this. And gamma function is also a factorial function, and we can just simply say like it's a generalized factorial function similar to this normal factorial function. And here we are just giving some kind of integral values like 1, 2, 3 and so on. All right, so we know how to calculate 5 factorial. Like 5 factorial is 5 times 4 times 3 times 2 times 1, right? And we know how to calculate 3 factorial similarly, and 4 factorial, and suppose if you wish to find like 50 factorial, we can even find those factorials, right? So we know some of the properties of factorial function, that is n factorial is equal to n times n minus 1 factorial and so on. So suppose if we are plotting this factorial function, we have a x-axis and a y-axis like this. Suppose if we are plotting, suppose for 0 factorial is 1, and about 1 factorial is again 1, and 2 factorial will be like 2, and 3 factorial will be 6, and 4 factorial will be like 4 times 3 times 2 times 1, that is 4 times 3 times 2 times 1, that will be around 24. It will go like this. So if I'm just plotting and interpolating this function, I will get a certain kinds of interpolated curve like this. Okay, it's just similar to some kind of exponential graph, but it's not even like exponential, it's just growing rapidly. All right, and suppose if I wish to find 3 factorial or even 10 factorial, I can't directly find using this factorial function. Suppose if I wish to find 5 by 2 factorial or even 1 by 2 factorial, how can I find that? So we just need a generalized expression for that. From this factorial function, we generalize it into gamma function. That means gamma function is a generalized factorial function. Suppose if I'm just drawing a certain kinds of curve like this, so this have all those points in it, right? This have all those points in it, but actually in between it shows some kind of deviations, that there can be a lot of functions in between, a lot of oscillating functions, which includes this 1 factorial, 2 factorial, 3 factorial, 4 factorial, like that. There will be a lot of functions. So in order to calculate this 5 upon 2 factorial or even 1 upon 2 factorial, we have to generalize it. All right, so here comes the importance of our gamma functions. We generalize gamma function to gamma n, and the definition of the gamma function is given by gamma n is equal to integral 0 to infinity x raised to n minus 1 e raised to minus x dx. All right, where x is a dummy variable that we use. So this is the generalized expression for the gamma function, so which is the basic definition of our gamma function, and we will be dealing this expression to do a lot of problems, a lot of mathematical problems. All right, so we are just going to show that gamma 1 equals 1. Okay, so we have to show this relation. All right, it's too simple. Like we can just simply substitute for n over here, like gamma 1 will be equal to integral 0 to infinity x raised to 1 minus 1, x raised to 1 minus 1 e raised to minus x dx, which is equals integral 0 to infinity. This will be 1 and this will be identified as e raised to minus x dx, and on integrating we'll get e raised to minus x upon minus 1, and we have to substitute the limits. X equals, lower limit is 0 and the upper limit is infinity, and if we calculate, this will be equal to e raised to minus infinity upon minus 1 minus e raised to 0 upon minus 1, which is equal to this becomes e raised to minus infinity, that is minus 1 by e raised to infinity minus of minus 1, that becomes plus e raised to 0. This is 0 and answer will be 0 plus e raised to 0 is 1, 0 plus 1 is 1. So we got as one of the basic relation, like gamma of 1 equals 1. All right. So next we are going to learn some of the fundamental relations of gamma function, and the first relation that we are going to learn is, the first relation is gamma of n plus 1 equals n gamma n. All right. So generally we know that the gamma function, by the definition, we have gamma function equals integral 0 to infinity x raised to n minus 1 e raised to minus x dx. So this is the general definition of the gamma function, and by integration by parts, we have first function times integral of the second. So we have to substitute the limit over here minus integral of derivative of the first, that means n minus 1 times x to the power n minus 2 times integral of the second all right. So this will be equal to x raised to n minus 1 times e raised to minus x by minus 1 times 0 to infinity minus n minus 1 times integral 0 to infinity x raised to n minus 2. The integral will be raised to minus x by minus 1 dx. All right. And we have, if you substitute the upper limit, like e raised to minus infinity, the term becomes 0, and minus of this term will be like, we have to solve the e raised to minus x by the power series solution. So we can just take the Maclaurin series and we can just limit x to 0. So the upper limit e raised to infinity gives 0, minus of this minus 1 gives plus, and we have to limit it to x tends to 0 by the Maclaurin series expansion. Limit x tends to 0. So the Maclaurin series expansion of e raised to minus x is 1 minus x upon 1 factorial plus x squared by 2 factorial minus x upon 3 upon 3 factorial plus etc. So we have to generalize, like, so for the odd powers of x, we have minus terms, that is minus 1 raised to n raised to n times x to the power n and x raised to n upon n factorial plus etc., and it goes up to infinity. And we have to substitute that x raised to minus 1 term over here, x raised to minus 1, x raised to minus 1, then this minus and the minus of this becomes plus, which becomes plus of n minus 1 times integral of 0 to infinity x raised to n minus 2 times e raised to minus x dx. Alright, so we came up to this, and if you substitute this x raised to n minus 1 upon here, and if x tends to 0, the first term becomes x raised to n minus 1 and the second term becomes x raised to n minus 2. Like that, if you substitute for x, the whole series will give the value of 0. So 0 plus n minus 1 times integral of 0 to infinity x raised to n minus 2 e raised to minus x dx. All right, so this is like gamma of n minus 1, right? This is like gamma of n minus 1 from the definition. So we will get n minus 1 times gamma of n minus 1, right? So we got a relation like this: gamma of n is equals n minus 1 times gamma of n. That is, gamma of n equals n minus 1 times gamma of n minus 1. All right, so suppose if you are just replacing this n by n plus 1, this becomes gamma of n plus 1, which is equals n gamma n. All right, so this is the one of the basic equation that we get from the gamma function, that is gamma of n plus 1 equals n times gamma of n. All right, so we can just deal other things in our next video. So up to this now, bye bye and take care.